me get started. Before we go deep into what machines have really done, let's understand how machines really work and what their functions. And one of the common things people think is their programming has been a case where Silicon Valley, software industry has been flourishing for decades now. And that's kind of machine learning many people think, but I want to break that myth and make people understand in a very simple example how that is quite different, and do a quick comparison between programming and machine learning, so that people get a sense like how the mindset has shifted. Most of the people have done some programming in some sort or the other, some language. In a programming world, traditional programming, we have a computer, a machine, a computing device. We have some input data. I've taken a very simple use case of just 1, 2, 3, 4. A programmer has been asked very specific prescribed rule. They have to achieve certain program. Let's say a very simple program in this case is how to find the square of a number. So each number has to be taken and squared. If everything works fine, no errors, nothing, this is going to be the output. 1 would change to 1, 2 would change to 4, and so on and so forth. That's been programming and a very set rules and prescribed set of instructions which the programmer is giving for the computers to perform. Now, how is that different? And isn't that sort of machine learning? No, it's not. In the machine learning world or data science world, we start with the similar thing. We need a machine, a computing device. We, of course, have input data, and I've just kept 1, 2, 3, 4, just to have apples to apples comparison. But here is where the difference starts. Instead of providing a set rules or a prescription what the machine has to do, we provide actually some examples or output for those scenarios. And here is a simple scenario which I have done. You may want to take a few moments to think about what's going on. If you look at the input and the corresponding output, 1 changes to 1, not much can be inferred there. 2 changes to 8, 3 changes to 27. And I'm sure many of you have already figured it out by now that this pattern is what is cube. So we human beings can take a look at that and analyze and very quickly come to an answer. It's a pattern of y is equal to cube of x. That's very straightforward for us if and only if there is only few number of data sets and the formula is simple. But as soon as it starts become millions of records and the pattern is not as straightforward as a cube or a simple formula, we human beings back out very quickly. And that's where the machines thrive. And they learn through this pattern and they can get to very complicated systems and answers which cannot be done in the traditional world of just doing rule-based programming. You cannot define a rule-based system to beat a chess game. There are thousands and thousands of iterations and combinations, but you could, as you know, very clearly this can be done by a computer and it has beaten the champions of the world. Not something which can be done by writing a simple program. It's not easy to find through images and say, this image is a cat or a dog, this image has a disease or not a disease, and so on and so forth. Not a rule which you can write very straightforward. There are so many exceptions and challenges, but it can be done by giving examples and enough number of examples. The key is having a lot of data. So hopefully this clarifies the difference between programming and how machine learning world is changing the overall landscape and how even challenging problems can be solved by machine in a very systematic way.